Yeah. Hi, Dave and Brenda. So my name is Gurupreet Sethi, and today I'm here to share the progress of my Spark project with you guys. So I joined the LJI back in 2019, and I got the Spark project in 2022. And my Spark project was, what if we could cure asthma by erasing the immune system memory of allergen? So first, I want to give you a brief overview or flashback of my original Spark project, and then I will describe what would be the extension of my Spark project. So the original idea of this project was to develop the bad memory cells of our immune system to the allergen exposure. And for that, we are using this protocol in our lab, in which the laboratory mice, they were exposed to house dust mice through on the multiple time, which are separated with the certain 2 or 3 weeks of resting period to which allow them to recover from this allergen exposure. And when we compare the naive mice with no asthma history, looks like this, which is very neat and clear, with the mice which were exposed to our experimental protocol, we found this kind of difference in which all these black dots, they are representing the bad memory cells, which are originally the T cells of our immune system. So our idea was to know more about these bad memory cells. And for this, we decided to sort out these bad memory cells of the lungs of mice with the help of our already standardized protocol in our lab, and then analyze them with the help of single cell sequencing. This is the way to know more about to know more about of a completely unexplored population. So we decided to proceed with this technique. And with our with our original project, we got this result in which we found that right here in the right hand side, we found that this bad memory cells is a cluster of different population, each color representing the a separate subpopulation of T cells. So the classically, the asthma is considered as the disease which is controlled by TS2 population of T cells. But now with the help of our Spark project, now we know this bad memory cell is not a single population, but it is a cluster of so many different population, and they are working together to control this disease. And when we analyze this result with the help of bioinformatics tools, then we realize that all of these cluster which are completely different from each other. And on the left hand side, we have that heat map information, where we have the different gene which are expressing at the different level in the different subpopulation. And on the analyzing of this result, now we know that other than TH2 cells, which is the top of it, we have the different subset of T cells like TH1, TH17, T follicular cells, CTL population. So now we know why our currently available asthma therapies, they are not working with some of the population of asthma patient, because we need to target these cells also in addition to TS2. So this is the major outcome of our original Spark idea. Like the memory cells which are developing in asthma patient, they are made up of 10 to 12 different population of T cells. And thanks to all the Spark donor uh, who believe in my idea, and now we know how many different bad memory cells the asthma patient they are developing. And in addition to this, during the extension of my Spark project, I decided, or I opted to target some other scenario of asthma patient which are associated with the asthma therapy resistance. The current scenario is that so many asthma patients, they are responding well to the asthma therapy, but once that therapy is they stop, they're gonna develop the asthma symptom again. So to understand this condition, I propose in during my extension Spark project to develop the long lasting asthma therapy. And for this, we decided to opt the same experimental protocol which we use in the original Spark project. And During this time we selected different kind of asthma therapy, and we decided to treat the asthma mice with these therapies. And so during the last year I was using the I was working with the different project in Croft Lab, in which we are using the different asthma drugs. The one of drug is like the anti-CD3, which are the co-receptor of T cells, which are controlling the response of T cells. And the another therapy was which are based on the co-stimulatory molecules. Again, these are the molecules which are regulating the actions of our T immune cells. So these are the two different asthma therapy I opted for this extension project. And we found that when asthma mice they were treated with this therapy, they resolved the most of the bad memory T cells when they analyze just immediate after giving these asthma drugs. But when we analyze some of these asthma therapy treated mice after a long period of time, when they expose one more time to this allergen exposure, this time we found that the anti-CD3 therapy, they were not carrying they were not they were not carrying their protective effect. So basically the protection provided by anti-CD3 therapy was very transient. On the other hand, the mice treated with costimulatory molecule, they surprisingly they carrying the same protection throughout this experimental protocol, even after getting exposed with the one more allergen exposure. So it seems like that these co-stimulatory molecules, that if the protection provided by these co-stimulatory molecules, they are really long lasting. So now our question is why these cells they are behaving so differently with the different asthma therapies. So to find out that question, the answer, we decided to analyze this population, which are still presenting in the treated mice, and the way we decided to analyze this population is the same what we did in our original Spark project, like to sort out these leftover cells and analyze with the help of single cell sequencing. And the main and so far we sort out this leftover population, and we already did the single cell sequencing analysis. We already did the single cell RNA analysis, and now our next project was now our next step would be to compare the our single cell data which we got with our original Spark project, and comparing them with the single cell RNA sequencing of the leftover population after treating these anti-CD3 and co-stimulatory molecule therapies. And our hypothesis was by comparing these two, by comparing these asthma therapy treated the T cells with their original asthma. So our main hypothesis was to comparing these two projects together to find out why this leftover population they are providing the transient protective effect with some therapy, and why they are providing a long lasting protection with some other therapies. And it will help us to find out it will help us to find out the novel markers of the memory cells that are making them responsive or non-responsive to asthma therapy. And at the end, I would convey my sincere thanks to all my team member, Dr. Croft, and I would also extend my thanks to all the Spark team, and especially all the donors who believe in my project, and also they decided to come along with me during the extension of my Spark project. And finally, thanks to you, Dave and Brenda, who always there to support my project. Thank you so much.